Yeah.
General relativity for babies. What's that? This is a ball. This ball has mass. More mass, less mass. See, this one's bigger and this one's smaller. And this is a flat space. Mass warps space. Less mass, less warp. More mass, more warp. This is a small particle. Small particle. It wants to go here. You see, it wants to go from point A to point B, but it can't. What do you think it's going to do? It must follow the shortest path through the curved space. This ball is spinning. Do you like to spin? Mass drags space. Space drags mass. See, it's going into a spiral. This is a flat space from a different angle. Angle. See, mass warp space from this angle. Shrink a large mass enough and it becomes a black hole. Big, big. You see, bigger, medium, small, tiny. A black hole is a large amount of mass in a relatively small area. They made the big mass into a little mass. See? A black hole has so much mass that not even light can escape its warp. I'm a black hole. I caught you. The center of a black hole is called a singularity. Can you say singularity? It's kind of a long word. Two black holes can spin around each other, and they send ripples through space called gravitational waves. See a spiral? These waves stretch and squish space throughout the universe. Now you know general relativity. Well, aren't we smart? This book is called General Relativity for Babies by Chris Ferrie. You want to read the Newtonian Physics one? All right, let's go next. Newtonian Physics for Babies by Chris Ferrie. This is a ball, and the ball feels the force of gravity. We can't see gravity. It is the force that keeps us on the ground. The force of gravity pulls the ball down. This ball is on the ground. It still feels the force of gravity, but it also feels the force of the ground. Like you're sitting on the ground. The force of the ground equals the force of gravity. The net force on the ball is 0. It doesn't change its motion. It's sitting still. This is a ball. The ball has a net force. It does not change its motion. It accelerates. This ball has mass. This ball has more mass. It's bigger. This ball has less mass. It's smaller. Let's see your hand. Big ball, little ball, big ball, little ball. More mass means more force. Less mass means less force. Small. Big. The force of the ground always equals the force of gravity. This is Sir Isaac Newton. He has 2 eyes, a nose, and a mouth. He wrote 3 laws of motion. You see this guy? When this apple falls from the tree, it doesn't float away. The apple feels the force of gravity. What happens to the apple when it falls from the tree? Let's see. Boink. Sir Isaac Newton feels the force of the apple. Boink. Boink. Now you know Newtonian physics. 1. Newton's first law of motion. If an object has 0 net force, it does not change its motion. 2. Newton's second law of motion. The net force is equal to the mass times acceleration. And 3. Newton's third law of motion. For every force, there is an equal force in the opposite direction. I love you. The end.